Okay, so this next module is on MOCA and the DLXD system. The first module having to do with how MOCA interacts with the discrete product is talking largely about the inventory model. We'll gain an understanding of the important attributes of the model, some key issues in area setup, relationship between areas, locations, loads, load subs, and details, and be able to gather information about the system via SQL. The basic data model is, and we'll go through this the next couple slides, we'll go through this in various different ways. Essentially boils down to warehouse, area, location, pallet, case, pieces. In terms of we'll talk about in subsequent modules additionally is order line, order notes, how the shipments relate to orders, and kind of how the shipment models work together and link back to the inventory model. So this is a diagram of the current inventory model. Basically, it shows you, and I'll show you on the next couple slides additionally, kind of more depictive of how this works. But essentially, area is at the top. Area relates to warehouse. Area contains locations. Locations contain loads, etc. We'll talk about this very specifically here. So let's just go through this. Obviously, we have the warehouse, building, and area. Area is really kind of where the inventory models, really the heavy-duty bits of the inventory model start. Now, we have connections from the area to the building, but really the main connection is warehouse to area. And they have attributes that has to do specifically with processing in the facility. The loc-mast, the location master, has information about storage locations, the area it's in, specific attributes. The INV load table contains load numbers. Typically, that's going to be a pallet ID, the current stow loc, some other information. The subload table is the INV subtable. That's going to have the sub number. Typically, that's going to be a case ID, though. We'll go through a lot of information about why that isn't always the case, or actually is a lot of the times not the case. Some sub-UCC information, and the actual detail record is the thing that contains the information about the inventory. So let's talk about areas. And I always tell people that when I get pulled onto a project to help, the first thing I do is look at the area setup. The area setup tells me a lot about what's going on in the system. So the two things that I mostly look at is the area setup and move inventory to see what's going on with move. Just those two things, when you're fresh on a project, will tell you a lot about what's going on with the system. So there's a couple different reasons to have different areas. We have logical differences. You've got high flow-through area in the facility. You want these sets of locations treated differently than these. You want to store certain products in this area versus another area. Those are logical reasons. There's also physical reasons. Certain area has pallet rack. This certain area is shelving. This one has flow rack. This area houses receiving. This area houses. So we have physical reasons and we have logical reasons for having different areas. As I said here, I take 5-10 minutes if I'm new on a project just to get in there and see what's going on with the areas. Here's kind of some of the technical. And what we talked about just briefly here for the past couple minutes is really covered in the setup class, and I'm sure most of you have been through that. The reality, though, is there's a lot of technical stuff that goes on in the system that is very specifically tied to the area setup. That's why we're going to spend a couple minutes talking about that. Storage hierarchies, so that's how we look at deciding how we're going to put stuff away. And the thing that we always say is, look, if it's put away well, it's going to be picked well. So the put away logic is really important as far as the flow of the system. Movement paths. This is basically saying if I'm in this area, how do I get to that area? So all those things are defined at an area level. Any special processing, that's operationally, are you going to need to route through this area on the way out to do overpack or some other kind of special processing? That'd be another reason for areas to exist. Picking hierarchy, again, similar to the storage hierarchy, allows you to decide how you're going to flow your picks through the facility. Replenishment hierarchy works with the picking hierarchy, works in concert with that, but it's its own kind of special requirements, and there's actually another module just entirely on replenishments, if that's what you're looking for. And outbound staging, there's a lot that goes on with regard to outbound staging, programmatically and otherwise, that is involved in the area setup. Some things that implications, significant flag, that allows us to basically say whether something, we're tracking the capacity. Please, 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 use the significant flag and don't just say, set everything to, honestly, I've seen this, set everything to significant and set all the values to, 99999 for your max, because, we're always going to be putting stuff in there and we don't really care about it, right? The location capacity code, this really tells us kind of what, this is like the unit of measure. And when you go in there, it's like the unit of measure to say, what does the QVL really mean on a location? Processing area, this, I have to say, in my belief, is the most misused piece of the system and the cause of a lot of problems in implementations. We must very specifically decide when something is a processing area. Okay, if you want something to go someplace, that does not mean it needs to be a processing area. If you absolutely need something to go someplace, that means that's a processing area. And there's a big difference. There's a big difference between those two statements. I could say, I'd like you to put it over there, or I'm making you put it over there. Now, if I'm making you put it over there and that place is filled, you can't do anything until that place is not filled. If I say, I would like you to put it there, oh, that place is full, I'll put it over here. Okay, that's the difference between saying, is something a processing area or is something not a processing area, and we would just like to advise you to go there, but we're not making you go there. Processing areas are great for situations where you need them to go there because there's some processing that needs to be taking place. If you're like thinking a processing area equals a P&D, then you're thinking about a processing area wrong. So be cautious about this. We'll talk about this a couple times. Be cautious about making process areas because they cause forced hops in the facility. Okay, forced hops are sometimes necessary. For instance, if you're doing an overpack and you're bringing pieces down and they need to be overpacked and and dunnage filled in, and that's the only way this stuff gets out of here, all right, that's fair enough. That is a processing area. Or if you have special processing because you have some bad stuff going on, you have to label it or do whatever, again, fine. If you're just saying it would be great if we made them go there, oh, you're just asking for trouble. So in my mind, I'll tell you that's the way processing areas started in discrete is we needed a way to say this stuff's got to be consolidated before we get it out of here. Okay? So the whole idea about a processing area is entirely started with the idea of consolidations. Right? So we said, we don't want this stuff going to the ship dock until it gets consolidated with this other stuff. So let's make it all go to one spot and make it all be there in that one spot before it goes someplace else, right? So that's the whole idea behind this processing area thing, and somehow it's, from time to time it morphs into something where it, there's processing flags set all over the place, which just causes all kinds of havoc. So be very cautious. I go into a system and I see processing areas in more than one or two areas. It makes me suspicious about what's going on there. Again, consolidation, good use of processing area. Overpacking, that kind of stuff where you have stuff to do and it has to be done that way and all the pieces have to be there before you can do it, processing area. P&D, not so much. Okay. Lots of other reasons why you won't want to do a processing area. Or if you choose your processing area, choose them downstream so that we can get some advantage of the fact that they're as close to the shipping dock as possible. Shipping dock itself is a processing area. Why not use that if that is a consolidation area. Shipping dock can be a consolidation area. If you need something upstream to do consolidation where you're actually doing a smaller level consolidate, like for instance, we have to consolidate this stuff on a pallet and it has to all be there at the same time before it can move, that's one thing. So I realize I'm harping on this. It just causes us more trouble than it should, in my opinion. So let's look at the area to inventory part of this. And I realize this is a little bit of a contorted slide, but basically what it means is here's the top chunk of this where we're saying area to location master, basically area area code, loc-master area code, and then the warehouse IDs. That gives you the link between the area and the location. Likewise, the loc-mast, stow-loc to inventory load stow-loc plus the warehouse ID gives you the link down one. And then likewise it goes down, load to the sub to the detail. So here's another description of it. Area master contains locs, contains loads, contains sub, contains detail. We're going to come back to the slide in a second. Locations, physical attributes, capacity. So basically it's based on whatever the QVL means. The QVL basically is just a term we came up. We used to call it quantity, but then we thought, oh, we got a volumetric, so and then we have length, so quantity, volume, length. So it's actually quantity, volume, length, and pallet footprint, the lowercase p somewhere in there. But so those are those things. The current state, empty, full, partial, inventory error. Now one could really argue that inventory error is no real reason to be on the status of the location. It just happens to be there and never got moved. So that's no real rhyme or reason, like no real logical thing. It's just one of those things that it got on there and there's a lot of code around it, so it's not getting moved. Work zone, aisle, travel sequence, these are all physical things that have to do with work management sorts of things. Logical attributes, velocity zone, which is kind of quasi-related to physical, I suppose. It basically says, okay, is this something that we could see for faster moving stuff? Replen percentages, availability flags, usable, storable, pickable, replenishable. We typically don't play a lot around with those flags. We set them up the way they need to be set. But sometimes we will actually kind of tweak those flags a little bit, depending on if customers sometimes will have locations that they want to bring in and out of availability. These are typically like logical locations where they have the big staging locations for staging these big shipments that come across every once in every while. They'll set up a bunch of locations like that, or a few of them, really big, like they'll have 50 pallets in them. And they'll only put them on when they're going to release some big wave. So sometimes we actually do write little DDAs that allow them to very quickly say, okay, I'm going to do this kind of shipment, and I'm ready to do this, and it does everything it needs to do to set those locations up. There's some other things that typically go along with that, resource codes and things that might have to be set in order for that to work really well. That if you do that in a DDA, as opposed to them saying, okay, go on, turn on, make it usable, and set the resource code to this, and that makes it a lot easier for them to do that if they're doing that sort of thing. Okay, the load table, INV load table, most often thought of as pallet table. Could be a tote, could be a container of some kind. Could be just a placeholder. Okay, a load does not necessarily mean a pallet. The more accurate way of thinking of a load is the largest movable container of inventory. I put an asterisk there because I'm not counting inventory outside the four walls in the yard. That's a little bit of different as you get into yard stuff. That's a little bit different animal once things get into movable trailers and things like that. It is in fact the only inventory construct that moves. Not counting the yard stuff. So let's just say this. If I'm moving only a case, what happens? Well, a case must exist on a load. It cannot exist connected to a location. So we're either going to move a load or we're going to move it from one load to another load. So those are the only real two options we got when we're moving a case. Now, why that happens? We actually experimented a lot with this data model, and Jim Heflin designed this data model probably about 15 years ago when we were doing some work at Compaq. And we designed this. We designed a couple iterations of data models that were much more fluid, like didn't have connections. Would basically allow you to put a sub on a location and put. So we did all this stuff. Now, so imagine that, right? And then now imagine you saying, "Hey, what do I have in this location?" Oh, that's a nasty select now, isn't it? Because you always have to be looking at all those levels to get, and you uniquely have to join those, right? So you would have to do a very nasty union to actually get the data back. When we were first prototyping out the idea of not having these connectors in there, not having, potentially having a detail record connected to a stoloc, man, just to look at inventory, the select was massive. Just to say what's in a location. Then if you think about how move needs to work and how many iterations of things, so we just had to make a call and say, look, if we have this structure, and did the DM Plus product, the LDM Plus product, attempt to do that at some point? Did it do that ultimately, or did you eventually get to the point where you just were doing solid structures?
No, we haven't.
Oh.
Plus anymore.
Yeah.
It's been a long time. 4. Plus 4 was the last time.
Mike says he doesn't have a frickin' clue. So,
I think the same way up to version 6.
Yeah.
It's just a low level.
Yeah.
It's a foreign.
So when we designed this structure, we basically, and you'll see this in the other areas of the data model. This data model was designed with Compaq Computer Corporation in mind. So Compaq now is HP, got sucked into the HP thing. We did all of their distribution. This product, the first things that it did was run all of Compaq's distribution centers and raw materials warehouses. So the system data model was designed very specifically, and you'll see this not only in the data model for inventory, but the data model for the orders. You'll see that there's things in there that you're like, well, why is it lot num rev level and origin code? Well, lot num rev level are pretty important to computer makers, right? And origin code, we actually had a lot of origin code in there, origin code stuff in there, so that we weren't shipping things that were made in mainland China to Taiwan and that sort of thing. So origin code tracking, and we have inclusion lists and exclusion lists, which actually now have been a declining feature for a couple of years because no one else uses them. But so this is an example of the fact that we had to make a call on how efficiently to do this. And the very first system that we implemented this on was and we had to make it efficient because the very first system that we implemented this on was a Compaq System Pro with quad 486 processors running a 250,000 square foot warehouse. So we had to be super efficient, and we couldn't do all this stuff trying to figure out where inventory was. We had to be very precise about it. So the nice thing about the discrete product is it really was designed from scratch to run on the smaller platform and be very efficient doing it. So in order to do that and work well with the database, we had to make some calls. The call is we got 3 levels of inventory. Okay. Now there's some additional stuff you can do with serialization beyond that, right? From some extra little serialized doodads that you can stick on there. But essentially, it's load sub detail. Now every once in a while we have folks come and they say they need 4 or 5, and you got to step back and say, wow, what is that? And there actually has been some movement to actually extend kind of our ability to do that with some additional attributes of data and things, which you could potentially do. But ultimately, it's going to boil down to its load sub detail stuck in a location. So that's kind of the history of how we got here. Some attributes of the load. The location, the permanent and movable flags, Permanent flag allows the load to exist with no inventory on it. Typically, if you have a load number, as soon as there's no inventory on it, the load number ceases to exist. A permanent flag allows us to use reusable containers like totes and expensive pallets, reusable pallets. The other thing that we had done in the past is we used to use permanent loads in situations where the load number was not significant in storage. So in a big parts distribution center where typically you're dealing with everything in pieces, we call that a part quantity tracked system. So we never actually even look at cases. It's all, I'm picking this part, this quantity from this location. At that point, what is a load? What is the significance of a load? As soon as it goes into inventory, it's just a piece of product in the shelf. And so sometimes what we would do is we would create permanent non-movable loads in all of those shelves. And now we did that, keep in mind that back then we were running on a 486 and we were having to do things. We didn't want to insert, we were like worried about that one extra insert of a load record when they did what, a put away? So I actually, when folks ask me about this now, I'd say, yeah, unless it's a reusable, movable thing, I wouldn't even bother making a load permanent inside of a location, even if it's part quantity tracked. To me, the payback is really insignificant now because, look, you're going to spend your time allocating stuff, right? You're not going to spend your time, we're not going to spend a lot of extra time worrying about, I got to create a load in this location because there's nothing there. It's really an insignificant thing. I don't know what your opinion is about that.
I don't, since 4, I haven't used them since DCS 4. So.
Well, the last time I did, I used it as, we used it for Panasonic because we had 280,000 locations that were shelf locations, basically 280,000 shelf locations, so non-load tracked, basically part quantity locations, 280,000, something like that, locations. And my feeling is, if you say I don't need a load and you say I don't need a sub, maybe and you have like a couple 100,000 locations, maybe there's an argument to have it. But if you say I don't need a load, but I do need subs, I would say you don't need it because then if you're moving cases about, you're always going to be pretty happy moving pallets around. So I would say the only case where you're going to have the permanent flag typically is going to be if it's a movable permanent thing like a tote or some kind of expensive serialized load like a container or a reusable load pallet. Oh, by the way, you see this thing on the load called the unknown flag. Anybody ever really look at that and say what is that? Well, that unknown flag on the load was used in cases where, like if you're dealing with a sortation system and packing out a pallet, sometimes, because we're scanning all the stuff, we want to make sure we know exactly what's on a pallet. Some people say, I don't care, as long as I know it's on one of these 2 pallets. Okay, so what we'd do is we'd say, okay, yeah, we know this shipment is spread out between these 3 pallets. We'd put all the product onto one of those 3 pallets, and we'd mark them all as unknown. So we'd basically put them anywhere on the pallets, and we'd just mark them as unknown and say, we know it's on one of those 3 pallets. So I don't think we've actually done that. Again, that was one of those things where I think we did that because, at the time the PLCs weren't that great about giving us diverts and all that kind of stuff. Now I don't think I've done a system since Compact that we use that unknown inventory flag on the load. But that's, just so you know, that's what it's there. Subloads. Often that's thought as cases. The more accurate way to think of this is the only thing that can be attached to the load. Doesn't really mean cases, just means something connected to a load. It's really a misunderstood construct. The thing that I think of, it's one of 4 things, and this is just, I'll be interested in hearing from you guys. This is how I view it. It's one of 4 things. It's either a connector between the load and the parts in the load, okay, essentially a connector between the load and the parts in the load in an inventory tracked facility. A connector between the load and the logical cases on the load. in this case. So if you've got, if you've got a big load, it's not serialized cases, it's all divisible by the units per case. It's a connector between the load and the logical cases, the cases that can be computed off the inventory detail by doing that calculation. The subload gives you that connector between those two things. It's very similar to the first thing. A kit, so it's often, a kit, now it's physical. Now a case really, so in terms of this is the first instance of what we talked about where the subload is actually physical. So in a kit, you'll often have an overpack or item picked box with one or more distinct part numbers in it, or a serialized case. Serialized case could be a kit, but is often something like a computer with a serial number on it, or product with a UCC identifier, a serialized identifier of some kind, or an EPC tag on it. So those are the kind of the four things that you normally think of. And for the most part, and actually inside any facility can go through transition. When you put product away, it could be number 2 here, which is the most common thing that it is, which is it's just a connector between, there are actually cases on there that might be in units per case of 6 or something like that. But we don't actually have all those cases materialized into subs. We just have one sub there, and the only reason that we know there's that many subs, that many cases there is the computation on the inventory detail record tells us that. But as soon as we pick it and apply a UCC number, boom, that thing turns physical. So you could have situations where you have both non-physical subs and physical subs at any point in time. And how do you know? Well, there's a physical flag on the sub record. And as soon as it becomes something concrete, that physical flag should go on. As soon as, whenever it's a connector of any kind, or just a placekeeper, so you can do a SQL statement to join it, it's going to say physical flag no. And again, we have the similar things, permanent, movable subs. Now we've actually used, there's 2 ways to look at totes. You can look at totes as loads, which is the easiest thing. You can also look at totes as subs if you need to. Like, for instance, we've done situations where we move totes all over the place, and normally we like to think of them as loads because it's easier for us to deal with it. But then what happens is sometimes you got to stack those totes onto a pallet and deliver them in a pallet, and so then the permanent nature of those movable permanents goes down to the sub level, and so those totes then become movable permanent subloads. Right? So that would be an instance where instead of the permanent movable loads, we got permanent movable subloads. Out of our QA session, one of the questions that came up was, what's the role of the attachment strategies, or what some people call glomming logic, on the move inventory and the area setup? The predominant things that we do is set up for attach to any, which means that if there's an existing inventory structure in place, we'll attach to that so that we don't build up some X number of loads and subs in a location. The other is attached to none, and that means that we never want to lose our load-sub relationships. We always want that to be separate. For instance, if we're moving into a pallet area, we don't want to lose the notion that we actually have a physical pallet and just have all those subs get attached to some pallet in there that has 200 million subs in it. So always attach to any would be one of the main ones we do, and never attach would allow us to always maintain our distinct inventory no matter how we're moving it in that area. Okay, details, often thought as units. This is where all of the inventory is kept, all the details about the inventory is kept, and it is the record of, it's the source record for everything else in the system, right? So this thing drives all the rest of the stuff, all the rest of the views, all the rest of the summary tables, like the IMV sum table, those things get driven off of what's on the inventory detail table. The attributes, part, unit quantity, are the most often things that you want to get off of there. Now, we'll talk about this in a bit, but it's important to realize that an inventory detail can be split. It can be split for reasons that are arbitrary as far as you're concerned, but whenever you're looking at inventory, you need to make sure you're going after the sum by part number by like attributes, because we could split it and recombine it in various number of ways depending on how the movements are called. Lot num, rev level, origin code. As I indicated, this system was built in the 90s, in 92, 93 for Compaq. And our first customer, Compaq, had the requirements of status, origin code, rev level, lot number. Now, because of our architecture, because you could just, as far as the user is concerned, those inventory attributes can be anything, right? And they can all be like 20 characters or something. You can use it for anything. Now, could we have gone through and said INV ATR1, INV ATR2, INV ATR3? Yeah, we could have. But there's real questionable ROI for doing that. The amount of work and the amount of bugs that we'd have to track down to do that at this point, considering all the code that's in place. So, frankly, we call them these things internally, but you don't think of them that way. You think of them as new used flag, right? Or, condition code, or, whatever the customer's thinking they need in terms of an attribute. Now, actually, condition code might be a status. But I don't actually like people putting that kind of stuff in the status field if they can avoid it, because I think status is an important thing to say, it's new used. I want to put that in the status because I can just do this. Well, it's new used, and the fact that somebody ran over it with a fork truck, are those mutually exclusive things? It might be new used and destroyed, or new used and damaged. So I think that it's important to make sure that we make the right decision about that. And there's lots of ability to disguise those things as virtually anything. So those other attributes are there for us to use accordingly. Packaging attributes, units per case, pack, and the footprint code. Footprint code allows us to we could set up a default footprint, so case dimensions, size of the pallet stuff, on a SKU by SKU basis. But that is materialized and put forever onto the inventory details, so that if somebody goes and changes the footprint, okay, for other stuff that they're coming in that same footprint code, is that true that we actually just put the footprint code? I thought, I'm just going to take a break here for a second. I thought that we actually put dimensions. Did we materialize the dimensions, or we just put the footprint code on the detail? Okay. So we put the footprint code on the detail so that it's tied to the inventory detail. Again, then the last thing is the important thing here. The really important thing is the connections to the outside world also appear only at the inventory detail level, and the connections to the outside world are the connection to the shipment, if it's connected to a shipment, the receive key that it came in on, if there's a receive key that it came in on, so we can track this all the way through the process, which receive key, which gets us back to the vendor. So for instance, if you're going to do a QA, if we need to QA something or if something goes on hold, we can actually track this down pretty specifically. Now, I'm not going to say exactly, because if we're not serialized and we're putting stuff into a location with a bunch of other stuff, we could say, we thought the product was in there, but we have to go and see physically if it's still there, because depending on how the product went in there and came out of there, there might actually be some or not, if you understand my meaning on there. If it's not serialized, we don't know exactly. We can know where we think it might be. We certainly know where we think it might be. We don't know where it is for sure. Workref gets you a connection to the picking structures, and the comp key gets you the key to the outside world from component tracking perspective. So kind of going back to this idea of load sub detail, 3 levels of possible serialization, and I'm not talking about some of the additional serialization stuff that we've added in some of the component serialization stuff, but main levels of just straight inventory serialization. You had load, like a pallet tag, sub, a case number, D, and you could actually have serialized pieces within a serialized case on a serialized pallet. So that's very much the computer manufacturer model, right? You could have 3 different serialized pieces inside a serialized CPU case, and then that's going to be on a pallet with a bunch of other stuff, and they're all going to be uniquely identified. So typically, though, you're going to have 2 or less levels of serialization. You're going to have like a pallet tag, and that's it. You're going to have a pallet tag and a case tag. Or actually, what will happen is, if you got serialized cases, typically you won't even bother putting a pallet tag on the pallet unless you need it for somebody else. Because once you have a serialized box on a case or a box on a pallet, you know what pallet it's on, and you can identify the pallet by scanning the case. Some things that people have trouble with. Sometimes people want to think about loads as pallets. And I know, because mostly a lot of times it's true. For most cases it's true. If you get into a parts facility that only thinks about things as part quantity, that basically you can identify this by the fact that they got a zillion shelves, right? They got a zillion shelves. Load numbers probably don't have a lot of meaning when they're, the size of the locations like this. The load and the sub now are only meaningful from a bookkeeping perspective. The only thing that's meaningful in there really are the details. And the loads and the subs give you a means to link the details to the location. I really don't think that there's any real reason these days to do permanent non-movable loads. I mean, the one thing that we did at Panasonic was because they had the sheer number of almost 300,000 locations. It was just easy, and all shelf locations, carousel locations. Essentially, all the locations were this big. Back when we did that when we put that in '96, we were really battling that system from a performance perspective. We didn't want to do any inserts or deletes to anything if we didn't need to, so we made a permanent sub and a permanent load and a permanent sub there, so we could only have essentially only moving details around. Unfortunately, the problem is that the detail move is the hardest thing to do. A load move is insignificant. Even if you have to remove the load, it's an insignificant thing. Even a sub-level move's insignificant. The hardest thing to do is a detail move, and that's the problem that you have no matter what. So, having a little bit of an advantage here on the loads and subs really isn't. It's not significant with the performance levels that we have. We have other performance issues having to do with big transactions like allocate inventory and things that just by their nature are hard to get around. Moving a pallet and putting a pallet in a location, if you have the right glomming logic attachment strategies set up, it's not going to be a problem. The one thing that I would say is about details. Details are hard to handle. The biggest performance impact we have on moves side of things is on detail moves, when we have to move a detail. Now, it's easy if we're just moving the whole thing. It's trivial, because if you're just moving a whole load, you don't have to do anything with the detail. If you're doing a part quantity transfer, so if you're saying going to the shelf and I'm moving this quantity out there, the detail might have 100 pieces on it, and we're taking 3, right? So not only do we have to split that one detail, we have to create a whole new whole new inventory structure for the outbound side. That's why having this movable permanence is really not a significant thing, because the cost of all this is on the outbound movements anyway, because you have to split the inventory detail, which is kind of a big deal, because you have to copy all the attributes, and then you have to make a new inventory sub potentially for it, depending on how you're picking it onto your RF unit, potentially make another load. So when it comes time, moving loads is the easiest thing to do. It's only one update, depending on if it comes from an insignificant or significant area, some other bookkeeping stuff to do. Subs can be just as easy, depending on what's going on. Details are the most difficult, and they're frankly not that difficult. It's just a little bit of bookkeeping to do with the quantities and stuff like that. So some words on load sub details. If you start piece picking off of a load and you expect to do case picking and pallet picking off of that, you need to be careful about this. DCS, the discrete product, will assume that you have one broken case on a pallet, right? So if you have if the quantities, units per case, okay, unit quantity divided by units per case comes up with a mod, so it comes up with a remainder, we're going to say, oh, there's one broken case on that. And we know there should only be one open case. And then we're going to be case picking. If you're set up to case pick, we're going to be case picking the heck out of that thing, okay, until we get to that 3 pieces that are left, right? So it's important that, as we tell people, oh, yeah, you can case pick and piece pick, out of the same locations, it's really important to make sure that they understand DCS assumes that we're keeping inventory nicely contained here, and we're only opening one box at a time. That's the logic behind the move. So just kind of a question always comes up. What do you scan if anything can be serialized? So we have a STOLOC, a pallet ID, a sub-num, and a detail num, potentially. Got serialized things at various levels. Well, we have got this very handy component called Get Translated Inventory Identifier. It's going to figure out what somebody scanned and turned it into the thing that we think it is. So Get Translated Inventory Identifier will take a piece of data and figure out, is it a load number, is it a sub-num, is it a sub-UCC, what level of thing is it? And this is a very handy thing that we use for customizations when we want to add, our own ways of doing scans and things on there. If they want to add, for instance, we've got this, some of the manufacturers are going through this movement to the 2 of 5 labels, and there's some things in there that we're having to do customized for that, to handle that logic if they don't have it actually coming in correctly from all their vendors. So what it does, though, is it looks hierarchically, logically, kind of starting at the top level of the area and then kind of working its way down, looking to see if it can resolve the identifier. Very bad things will happen if we have an identifier that's duplicated at multiple levels. Okay? So here's the thing that happens sometimes. Identify, right? You identify stuff. And let's say they're having to identify serialized product coming in there, and they happen to every once in a while scan the wrong barcode, and they grab an identifier, like they accidentally scan the load number into the sub-number field. Okay, if that actually happens, the identifier will probably work, but the next time somebody needs to go in there and say what's going on with this, at some point, depending on where they are in the process, you may hit an error because it's trying to resolve that identifier, that load number, to both the load and the sub, and not know what's going on, right? So what will happen is, as soon as that box leaves that load, you're in for real trouble, because now we think it's a load, that sub number, which has the same identifier as the load number, is going elsewhere. So as soon as somebody does get translated inventory identifier, we think we're talking about a load, and you're actually talking about a sub. So a lot of times we will put in a little extra logic if we're scanning serialized things to catch that. In fact, in the part maintenance, there's a way to put in a little check to see if you have serialized product. There's a little chunk of data that you can say, here's kind of the configuration of my serial number. It's got to be these sets of characters in this position. So if they scan this, I know they're scanning a serial number as opposed to a load tag. So that's very handy if you want to catch that. Otherwise, a lot of times we'll put in just a quick little thing to make sure that a sum number or whatever that identifier is, the serialized identifier looks like a serialized identifier. It's a quick little thing that we can do up front that will solve this problem in the longer term, because if this happens periodically, you get weird inventory issues pop up, and they're hard for our friends over here in the support group to track down. So we highlighted some of the important aspects of the inventory model. We looked at several issues regarding the area setup, important issues there, relationships between the areas, locations, loads, subs, and details. And we looked at ways to do selects against the various tables to get the data back. Out of our QA session, one of the questions that came up was, what's the role of the attachment strategies, or what some people call glomming logic, on the move inventory and the area setup? The predominant things that we do is set up for attached to any, which means that if there's an existing inventory structure in place, we'll attach to that so that we don't build up some X number of loads and subs in a location. The other is attached to none, and that means that we never want to lose our load-sub relationships. We always want that to be separate. For instance, if we're moving into a pallet area, we don't want to lose the notion that we actually have a physical pallet and just have all those subs get attached to some pallet in there that has 200 million subs in it. So always attach to any would be one of the main ones we do, and never attach would allow us to always maintain our distinct inventory no matter how we're moving it in that area.